So we're actually going to backtrack, and we're going to look at lessons 5 and 1, and we're going to talk about word problems. So we'll talk about lesson 5.3 next week. And these would be word problems involving inequalities. Oops. And today's date is 2/5/16. So we've talked back, several months now on words that told us to add, words that told us to subtract, words that told us to multiply, words that told us to divide, words that told us to put in parentheses. And what I need to share with you today is words that tell you inequalities. So I'm going to start by giving you an example, a comparison of how something that you're used to hearing, how it can get changed just a tad, and now instead of writing it the old way, we're going to write it using an inequality. So here's my example for writing down. 4 less than x versus 4 is less than x. Okay, so let's look at the first one. This is what we did before. How would we translate that into an expression? It would be an expression. 4 less than x.
X minus 4.
Okay, x minus 4. So Caitlin realized not only does less than mean subtraction, but it also is a switcher phrase, and I need to turn around what I have. Okay. The reason why it's just an expression is because there was no verb in that sentence. It's just a phrase. There's no verb, and the verb usually plays the role of the equal sign, so we couldn't do anything with that. Now, look what happens on the right side. It says 4 is less than x. But if we translated it like what we're used to, we would say 4 is less than x, and there's a blank. So that doesn't make sense. So what you need to do is look at this as a whole. Is less than now gets translated into an inequality. So when I pair an equal word with an inequality phrase, I now have an inequality, and what I get is 4 is less than x. That is makes all the difference in the world when it's paired up with those other words. Okay? So that's what we're going to talk about today. First off, what are some phrases to be aware of, and what do they mean? Okay, so we'll start with is less than. And it would just be the less than symbol. So the opposite to is less than would be is what? Is more than, is greater than, is older than, is taller than, and so on and so forth. And that's just the inequality greater than. Okay? But those aren't the only words that you're going to hear in a word problem that indicates, oh, I'm going to have to use inequality. You're going to start hearing words like at most. Sometimes you'll have is at most, so I'm going to put parentheses. Sometimes it's just at most. So think logically, what if somebody says, oh, that's at most 12? What are the possible answers if at most it could be 12? Chase.
Less than or equal to 12?
Yeah, it could be 12 or anything smaller than 12. So that's going to be less than or equal to. So when we have these qualitative words, it actually gives us an answer that's a possible correct answer. Whereas is less than means the number that comes after this is not an answer. It's not included in the solution. So what would be the opposite to at most? What? At least. Now, sometimes it's just the phrase at least, and sometimes you'll hear is at least. And think about what that means. If somebody says, oh, they're going to score at least 20 points, the Broncos in the Super Bowl. What does that mean? If they were going to score at least 30 or 20 points, yeah, the minimum they're going to score is 20 points. They could score more. That's the weird thing. The relationship is somewhat opposite to what we think. So at least would be, it could be this number or it could be more. Okay. Let me think if I can find any others. Okay, here's a couple more. This one is no more than. So think about it this way. You can have no more than 2 cookies. So what are your options? Yeah. You can have 2 cookies or you could have less than 2 cookies. So this would be another less than or equal to. And then its counterpart would be no less than. You hear your parents, you can have no less than a C if you expect to drive in this house. Okay, in all your classes. So they're saying C is the minimum. It could be better. So that would be interpreted as 8 greater than or equal to. So you could have that number or you could have more. Okay, so this is your minimum. So you can think of the words minimum, is going to be this kind of idea versus a maximum. Is now going to be the other direction. So you may not see the words minimum and maximum, you may, but again, think about those words. If you take your phrase and say, can I replace that with minimum or can I replace that with maximum? And maybe that will help you. Okay. All right, so let's do a couple of examples and see how they go. We're going to have a lot of, I gave you some very kind of straightforward ones. On page 289. I think most of them are pretty, kind of like a one-sentence word problem. I did give you a couple where you had a scenario going on that was more real world. So we're going to do an example that's just kind of a basic one, and then we'll do one that has a little bit more going on. So I saw a good one over here. Actually, I saw it in the next one. We'll just do these. Okay, so the directions are just going to tell us to solve. And the question will actually reveal what it is they want us to solve. So we've got Felipe needs for the temperature of his, where did they get these questions from? This is funny. Leopard gecko's basking spot. To bask in the sun was what most of the teachers were doing when you guys were taking your panoramic picture. We were standing and letting the sunlight beam down on us and warm us up. Lizards love to hang out on rocks and they bask in the sun is what it's called. Okay, so Felipe needs the temperature of his leopard gecko's basking spot to be at least 82 degrees Fahrenheit. Currently, the basking spot is 62.5 degrees Fahrenheit. How much warmer does the basking spot, how many times can you say basking spot in one problem, need to be? Now, what we're not going to do is launch into trying to figure out what the answer is. We're going to actually come up with an equation. Okay? We're going to come up with an equation. So what is it that we need to figure out? So what's our unknown in this problem? Okay, so it deals with temperature, right? So the amount, the temperature needs, in what direction is it supposed to go? It needs to rise, right? So the amount the temp needs to rise. Oh, it'll come and join us. There it is. Okay. Now, let's find a phrase that tells us equal, less than, greater than, less than or equal to, greater than or equal to. What phrase are we going to use for our inequality?
At least.
At least. So at least, is that a minimum or a maximum? That's a minimum, right? It's a minimum. So when we have at least, it could be more, so that's the greater than or equal to sign. Okay. So let's put this all together. We have a temperature. We need it to rise to meet a minimum temperature of something else. Tell me what to write. What do we have?
82 and 62.
Nope. We don't have 82. What do we have?
62.
We have 62.5 degrees. What do we need it to do? Rise. By how much? So if we rise, what math would you think that's going to be? We're going to add our x. And then that's got to be minimally, at least. What is the target number we want? And this is the lowest target number. Okay. Now we're ready to solve. All I have to do is subtract 62.5 from both sides. Now, this brings up a little bit of an issue in that there's no number to subtract the 5 from. So we're going to adjust our 82, putting in a decimal point and a 0. And I can't do 0 take away 5, so I'm going to rename this 2 into a 1 and change the 1 that I took and put it into 10/10. All right, so now I'm going to start doing some subtraction. So I get x is greater than or equal to, let's see, we get a 0.5. Oop, I have to rename again. And we get 11 take away 2 is 9, and 7 take away 6 is 1. So now we need to interpret this answer. So how would I write my answer? I'm not going to just write it as a number, as I was able to when it was an equation. I really need to interpret, because this isn't the only possible answer. So what would I write as my final answer? Jake?
Like as a sentence?
Yes.
Or, the temperature needs to increase by at least 19.5 degrees.
Okay, I like that. So the temperature needs to increase. Did you say by at least? Is that how you? Yeah. By at least 19.5. And here's where we have to add labels. What are the labels for the temperature here? Degrees Fahrenheit. So using that word at least says it could be more. Now, if you wanted to write it without the words at least, you could say the temperature needs to increase to 19.5 degrees Fahrenheit or more. We always need to clarify that this isn't the only answer. This is the beginning of the group of answers that you have. Okay? All right, cool. So notice what math went on in that problem. Well, when you wrote the equation. Addition. And remember what lesson 5.1 had adding and subtracting in it? Let's do one of the easier kind that you'll see from this lesson. Twice a number increased by 4 is at least, no, let's change it, is at most 10 more than the number. I don't know if this is going to mess it all up. So twice a number increased by 4 is at most 10 more than that number. Actually, let's try this. I think I'm going to change more than to less than. So isn't this kind of strange? We have words that mean inequalities and words that mean operations, but they sound like they mean the same thing. That's where we have to distinguish between them. Okay, so what are we solving for in this problem? What do they want us to find? Some number, right? So x is a number. Okay, so how do I write twice a number? 2x. Increased by. What's increased by mean? Plus. 4. I think we all know what 4 is at most. So is that a minimum or a maximum? Maximum. So it means I could have smaller answers. So that's my less than or equal to. 10 less than. What does that tell me to do? Subtract 10, switch your phrase, the number. And that would be your x. So notice less than did take on its traditional role to mean just subtract because it didn't say is less than. That makes it the inequality. All right, let's solve it. I need x's together on the left. I'm going to subtract x from both sides. I need constants together on the right. I'm going to subtract 4 from both sides. I get x is less than or equal to, signs are the same, so I add negative 14. Okay, so now I need to write the answer as a sentence. So what am I going to say about my number? Okay, I'm hearing mumblings. I can't really hear what anyone's saying. Okay, we can't say the number is negative 14 because we don't have one answer for these inequality problems. We have a lot of answers we could choose. Marlene?
Negative 14 is greater than or equal to.
Well, remember, what are we solving for? What are we solving for? The number. That should be how we start a sentence, right? The number is, you guys are saying less than or equal to negative 14. You could say it that way. That would work. You could say the number is negative 14 or less. There's a lot of different ways to actually write this answer out. Okay? All right, good. Let's go and talk about in lesson 5.2. Let's see what a word problem would sound like in that one. That's where we were using multiplication and division. So number 3, of the students surveyed at Madison High School, fewer than 84 said they have never purchased an item online. This is about 1/8 of those surveyed. How many students were surveyed? Okay, so what are we solving for? Don't tell me X. Number of students surveyed. Yes, we can use X. Oh, hello. Okay, number of students surveyed. So what do we know about the number of students surveyed? What did they tell us about a group of them? Chase?
84 of them don't buy anything online.
Okay. It didn't say 84.
Less than, fewer than.
Fewer than. So 84. Okay, that kind of is a key phrase right there, that fewer than. In fact, what do you think that phrase tells us to write? Huh? It's a less than inequality. Okay, so we're going to have this. So then that next sentence says we've got 84 kids, fewer than 84 kids. This is about 1/8 of the students surveyed. So that 84 and the 1/8 student survey mean the same thing. So how do I write 1/8 of the students surveyed? What would I write for my equation? 1/8 x is less than, because remember what the number said? It said fewer than 84. It didn't say 84 students had never purchased anything. It said fewer than. Okay, fewer than. So then we would solve this. What math would I do to solve this? Yeah, we'd multiply both sides by 8. Does it make sense that I'm going to get an answer that's greater than 84? Okay. So let's see, we get 32, we get 64, and 3 is 67. Okay. So what does that tell us about the number of students that were surveyed? How would we write our response?
There were fewer than 672 students surveyed.
That's about as crystal clear as you can write it. Good job. Fewer than 672 students were surveyed. We don't know if it's just a tad under that or a lot under that because they said fewer than 84. They could have just randomly picked 84 and it could have been 6. You know, we don't know. Okay? Yes, Jake.
Did it say it was about 1/8, so wouldn't it, should we include about somewhere in there?
Well, part of the about is also regarding the 84. Because it said fewer than 84. So 84 is not exactly the same as 1/8. So that's why we can get away with writing it the way that we did it. Okay? All right. You guys want one more or are you good? You good? Okay.